Analyze linear equations y equals mx. In 7th grade, we explored in great detail proportional relationships. Proportional relationships are when two quantities that have the same or a constant ratio. Here is an example from an anchor chart that is presented within our classroom. As a reminder, when working with proportional relationships, the y variable depends on our x variable. And in this problem scenario, money earned depends on hours worked. So that is why hours worked is labeled as x and money earned is labeled as y. When this person worked 1 hour, they made $12. 2 hours worked, $24, and 3 hours worked earned $36. We learned last year that in order to have proportional relationships, there are a few things that need to hold true. The first is that when you set up your ratios of dollars per hour, the ratios need to be equivalent. There needs to be a constant rate of change. And as you can see from all 3 of your ratios, they have a value of 12. And in this case, this is represented as $12 per hour. Since their ratios are equivalent, we know that there is a constant of proportionality or a constant rate of change of 12. The most important piece that is going to be utilized in our 8th grade curriculum is that these relationships can be represented by an equation. The equation you learned last year was y equals kx. So in order to determine how much money was earned, your y, you multiplied 12, or your k, by the number of hours. So that is why the equation for this problem scenario was y equals 12x. We are going to transition from that equation of y equals kx into y equals mx to help us analyze these linear equations. We are going to focus on how does slope relate to the equation for a proportional relationship. So we are going to be looking at the slope of these lines and see how slope can now help us write the equation to represent the problem scenario. Write an equation to describe the relationship shown in the graph. So off to the right, we have a graph discussing distance per gallon, where our x values are discussing gasoline in gallons, and the y-axis is discussing the distance in miles. So in order to write this equation, we first need to find the slope of this line. Since we are given the graph, there are 2 different ways to find the slope of this line. We could identify the rise and the run from one ordered pair to the other, or we can use our slope formula. In order to use the slope formula, we need to identify 2 points on the line and then find the change in their y values compared to the change in their x values. One ordered pair that is given to you is when x is 4 and y is 80. And I'm going to identify the next ordered pair that is the closest, which I could see would be this ordered pair right here. So actually with my pen, I am going to plot that this ordered pair is the closest to 480. And the coordinates of this ordered pair are 360, because x always comes before y. We are now ready to use these 2 ordered pairs in order to find the slope using the slope formula. Begin with the first ordered pair of 360. Well, we know 3 is the x coordinate, So this is our x-coordinate on the first ordered pair, which means that 60 is the y-coordinate on the first ordered pair also. X of 1 is 3, y of 1 is 60. Now we have to label also our second ordered pair, where 4 is the x-coordinate on the second ordered pair, and 80 is the y-coordinate on the second ordered pair. Now we are ready to take those numerical values and plug them into our slope formula. Y of 2 is 80 minus y of 1 is 60. So we need to plug in any of our missing values from our work shown. So we said that y of 2 is 80, which they have shown us right here, minus, what should we plug in for y of 1? Well, going back to my first ordered pair, y of 1 is a value of 60. X of 2 minus x of 1. X of 2 is a value of, we see right here that it is 4. And they properly plugged in that x of 1 was 3. So all we have done is plugged in those numerical values, and we are now ready to calculate the slope. 80 taking away 60, 4 taking away 3. If you were to use your scientific calculator, 80 taking away 60 has a value of 20. 4 taking 3 away has a value of 1. So our slope of our line has a value of 20 to 1, and that means that it is 20 miles for every 1 gallon of gas. That is the explanation of our slope in the context of this problem. Now we are ready to represent this as an equation of y equals m of x, where we are learning today that the variable m just is our slope of the line. So now that we know that our m is a value of 20 over 1, we also know that 20 over 1 is equal to 20. So the equation of this line is y equals 20x. In this lesson, we have learned that y equals mx and y equals kx are equivalent. We are working with m representing the slope of this line. And these equations of y equals mx can help us analyze these linear equations.